Hello and welcome. So, we're going to simplify each of the following complex expressions below. First thing you see, as soon as you see negatives inside of square roots, bells should be ringing. These are complex numbers. Now, complex numbers give us a definition, and that I is the square root of -1. Meaning that whenever you see a negative in a square root, what's going to happen, let's look at just this first problem. Right? What's going to happen is that we're going to see this whole thing. I'm going to copy and paste down here. Failed. It's fine, I'll just write it. -2 plus square root of -121 plus 19 minus square root of -4. Okay, you'll notice I left some space before each radical because when we use this definition that I is the square root of -1, what happens is that the negative essentially moves outside of the radical as in I. So as soon as you take the I out, that is the negative. Right? As soon as we take the negative out, that's the I. You notice I just said that two different ways. Okay? Anytime you have a negative inside of a radical, that is an I on the outside of it. That's the first thing you do. Period. Whenever you see negatives inside of radicals, always pull out the negative as an I. Always. That's just the definition. Okay, and now that it's pulled out, now you can worry about doing simplifying or any other properties of radicals. Now radicals act as they should. Go from there. Right here, 121, that simplifies. That's 11 times 11. 11 doesn't break down further. There's two of the same thing, and it's going to multiply to whatever's in front, the I. So we have -2 plus 11I. Okay, on the next one, the I will come out, right? 4 is 2 times 2. A 2 comes out in front of your I. So then we have plus, parentheses, 19 minus 2I. There you go. So now you simplify the expression more. Next question. We have these parentheses. Are they needed? No, they're not. Because as we're looking at this, there's nothing being multiplied or subtracted to these parentheses. They're not necessary. So if you just bring -2 plus 11I down, there you go. On this next parenthesis, because this is a plus, this second set of parentheses, also not needed. You can just bring it down, right? And then you can combine any like terms. Numbers combined with numbers. So 19 minus 2, 17. And i's combined with i's. So 11 minus 2 is going to be plus 9i. Okay, remember it's like if you have 2x plus 3x, you would get a total of 5x. The x doesn't change as you add or subtract. Same thing for i's. I's do not change as you add and subtract. They act exactly like x's would. Okay, but that would be it, right? You have an a plus bi form, right? There's nothing more you can combine. There's your first answer. Okay, now notice that the problem above is literally the exact same as the one below, except for one little thing, and that is the sign in the middle. So if we took all of that same work, right, but instead of this problem being plus in the middle, we're going to do a minus now, so -2 plus 11i minus 19 minus 2i. Okay, that's the literally exact same problem, right? You'd first take out the i's, right? Take out the I, break down to the 4, break down the 121, right? End up at the same place. Now we have this. And I'd say, okay, well now, same idea. Parentheses on the first one, are they necessary? No, there's nothing being multiplied, nothing being subtracted. You can literally just bring down your two numbers. Now in the second parenthesis, are the parentheses necessary? Yes, because of that subtraction. The subtraction is like distributing a -1. We'll multiply it to the first, so minus 19. Multiply it to the second, plus 2i, because a negative times a negative is a positive. And there you go. Now all of your parentheses are gone. Combine like terms. Numbers with numbers, still a thing. -2 minus 19 is -21. 11 plus 2 is 13. Okay, the I doesn't change as you change the quantities. Alright, there you go. And now it's still a plus bi form. There's your answer. Thanks for watching.